So, students, understood what is propionic acid fermentation? Any doubts in this?
No, sir.
Okay. How many of them are there? Very less. Okay. So that's one topic what we can discuss presently. So glucose becomes pyruvate, pyruvate becomes oxaloacetic acid. From oxaloacetic acid, completely there's a reverse of Krebs cycle where you get malic acid, fumaric acid, succinic acid, and succinyl-CoA. Up to succinyl-CoA, it is same. Okay. A reverse of Krebs cycle. Succinyl-CoA becomes methylmalonyl-CoA by isomerization. Methylmalonyl-CoA by decarboxylation becomes propionyl-CoA. Propionyl-CoA becomes propionic acid by removal of CoA and addition of water molecule. Thus, propionic acid is one of the important components in the cheese for flavor. And also the carbon dioxide which is produced here, the carbon dioxide locks inside the milk block, will form bubbles inside this milk block, and they will give the softness for the cheese. I think you have followed it. Just write one line or two lines on significance. That is the cheese production. Not fully procedure you need to write there. Only the principle you should say significance is production of cheese, where propionic acid is the flavoring agent. Okay, students. Shall we go for the next one?
Yes,
Yes.
sir.
Any doubts in this?
Yes, sir.
I'll go ahead.
Yes. Excuse me, sir.
Yeah. Tell me.
Sir, here the carbon dioxide is being fixed into the biomolecules, no, sir?
It's added in the substrate, like pyruvate is there, no? Carbon dioxide is fixed means not carbon dioxide fixation. Carbon dioxide is added to pyruvic acid with the help of a carboxylase enzyme. That time you'll get oxaloacetic acid. What is
so if oxaloacetate or malate is phased away from the cycle, is it considered carbon fixation like in Calvin cycle?
No. This is called carboxylation only, but carbon dioxide fixation is different there in photosynthesis. That is Kelvin cycle, no? That is for ribulose 5-phosphate. This is for pyruvic acid. There are enzymes like that in the cell. There are some enzymes in the cell which can convert 3 carbon to 4 carbon like that. Enzymes can do that.
So the carbon dioxide is taken from within the cell?
Within the cell. See here it's generated, that also is taken here. This can be taken here. This is a part of the pathway. See here. Methylmalonyl-CoA decarboxylase.
Okay, sir.
Enzymatic work, that is, enzymatic function. There it is carboxylase in plants. No? You got it?
Yes, sir. Yes, sir.
This is the bacteria is called Propionic. Name of this bacteria is called Propionic. In lower classes you would have studied the name of the bacteria. Wait, I'll just write the name here. See here. Propionic. Shermani. Shermani is the name of the species. Got it? This bacteria has a principle of producing propionic acid. They have these enzymes to do this work. Okay? Kalicharan, you followed?
Yes, sir. Followed, sir.
Okay. Now we will go to the next pathway. Let us discuss about the next pathway. What is it called? In your order, what is it? Acetic acid, I think so, no?
Yes, sir.
Acetic acid. Acetic acid fermentation. This is also desirable fermentation. Just like how you have the cheese production in propionic acid, like that vinegar production. It relates to vinegar production. If you see, in the PU, they have given this in very short form. There are instruments called as vinegar generators. These are called on drawing. Okay, in which here they will add the wood shavings. Okay, they'll add the wood shavings, strips of wood. Okay, on the, imagine this is a wood shaving. Then they will sprinkle glucose solution in this. Glucose will form a film on this. Understood? And then they'll add acetobacter. Acetobacter. Acetobacter is a bacteria which can produce acetic acid. Species can be called acetyl. Acetobacter acetyl. Okay. What they will do is this acetobacter grows on this as a biofilm. It will grow on the wood scrapings. Okay. When they grow on the wood scrapings, they will what they do is they will convert glucose to acetic acid. That's what we are trying to learn now. Their role is to produce acetic acid. Acetic acid is nothing but vinegar. You have different types of vinegar you will get. Low grade vinegar, high grade vinegar, etc. Different purposes they will use. So based on the requirement, they will buy. Sometimes they use apple cider vinegar like that. Means apple is fermented, you get alcohol. No, from alcohol directly they will convert by oxidation into acetic acid. By oxidation they will make, like in the lab. They'll convert alcohol and then they'll use this alcohol production in the from the apple or any fruit which is of their choice. That time that aroma retains in the vinegar. Apple vinegar, like that different vinegars can be produced. Okay, so that is used for food and also as a preservative they will use it, right? Vinegar is a very good preservative, remember. Okay, now we will understand with this background, we'll understand how this actually acetobacter will be able to convert glucose into acetic acid. Okay, students, now we'll go with the mechanism. You got the idea? Basic idea?
Yes, sir.
Okay, so what we will do now is we will start from glucose. Glucose converts to glucose 6-phosphate. Glucose converts to glucose 6-phosphate and that further converts into fructose 6-phosphate. I think you are familiar with these things. Glucose 6-phosphate and fructose 6-phosphate, just like glycolysis, what you have studied. These are 6-carbon compounds. Fructose 6-phosphate, which is a 6-carbon compound, will be splitting into acetyl phosphate and erythrose 4-phosphate. Acetyl phosphate and erythrose 4-phosphate. I think you can understand if I write short form now. Erythrose 4-phosphate. Acetyl phosphate is how many carbon? 2 carbon.
2 carbons.
Erythrose 4-phosphate is 4 carbon.
4 carbon.
2 plus 4, 6. Like that. So fructose 6-phosphate is splitting into acetyl phosphate and erythrose 4-phosphate. I'll come back to the enzyme a little later. First, we'll give the background. Acetyl phosphate converts to acetic acid. See, immediately acetic acid is formed here. Acetyl phosphate converts to acetic acid. Okay. How? Water is added, phosphate is removed. So acetic acid is formed by addition of water and removal of inorganic phosphate. This inorganic phosphate is removed will help in ATP synthesis. So you can just say that it will give ATP. Just represent it like that. Means ADP is using this AP and becoming ATP. ATP is generated. Now this erythrose 4-phosphate is there. No, this erythrose 4-phosphate can combine with fructose 6-phosphate. Once again. Right, short form. Erythrose 4-phosphate can combine with fructose 6-phosphate. Erythrose 4-phosphate is 4 carbon. Fructose 6-phosphate is 6 carbon. They combine together. 4 carbon plus 6 carbon and give rise to pseudoheptulose 7-phosphate, which is 7 carbon. And now what is left out now? 3 carbon. What is it? Glyceraldehyde 3-phosphate. I'll repeat once again. Erythrose 4-phosphate, which is formed here, combines with fructose 6-phosphate. 4 plus 6, 10. To give 7 plus 3, 10, which is pseudoheptulose and glyceraldehyde 3-phosphate. Again, they both combine and give ribose 5-phosphate and xylulose 5-phosphate. How many carbon? 5 carbon plus 5 carbon. So 7 plus 3, 10. 5 plus 5 is 10. So you get ribose 5-phosphate and xylulose 5-phosphate. Now these two will combine again, and now they give rise to 2 molecules of acetyl phosphate and 2 molecules of glyceraldehyde 3-phosphate. 2 molecules, I'll tell you, I'll explain that to you. 2 molecules of acetyl phosphate and 2 molecules of glyceraldehyde 3-phosphate. How do you understand this now? See, 5 plus 5 is 10. You should get back here. Acetyl phosphate is how many carbon? Acetyl phosphate is how many carbon here? This side you see. 2 carbon. 2 carbon into 2. 2 molecules, no? Became 4.
4.
4. Totally 4 carbon. Okay, this side. And that side you see what? How many carbon is glyceraldehyde 3-phosphate? Glyceraldehyde 3-phosphate is always 3 carbon. So here also you have, isn't it? Glyceraldehyde 3-phosphate is 3 carbon. So 2 molecules means how many carbon was covered there?
6 carbon.
6 carbon. 6 plus 4. 6 carbon plus 4 carbon
10.
becomes 10.
10.
No? Yeah. Means what we should understand here is at the end from erythrose 4-phosphate also we get 2 molecules of acetyl phosphate. Those 2 molecules of acetyl phosphate also converts into 2 molecules of acetic acid. So totally how many acetic acids you can get? 2 from here and 1 from here. So 3 acetic acids can be produced. And again here same way, just like how you wrote, water is added, inorganic phosphate is removed, ATP is generated. I'll show that 1 second. I'll show that. See here, you can show that here. 2 molecules of acetic acid is formed. Water is added, inorganic phosphate is removed, that gives ATP. Concept is the same, but 2 ATP you should show here. 2 acetic acids, 2 ATP is formed. So totally how many ATP is formed? 1 here and 2 here. So how many ATP is formed?
3 ATP.
3 ATP, 3 acetic acids. Okay. Now come back here. Come back to the glucose. All of you just go back to glucose now. Glucose to glucose 6-phosphate. What should happen? Phosphorylation should occur. No? ATP is used to become ADP. So ATP is used. Phosphorylation. Correct. Then glucose 6-phosphate to fructose 6-phosphate. What is it? Isomerization. Correct. Phosphoglucose isomerase. It's isomerization. Now this is fructose 6-phosphate will not form fructose 1,6-diphosphate. Fructose 6-phosphate is cleaving. So what is the name of the enzyme when cleavage occurs?
Aldolase.
Aldolase. Good. Aldolase. Acetyl phosphate and erythrose 4-phosphate is formed. Okay. Now acetyl phosphate converts to acetic acid. Correct. So what is the process here? Water is added, inorganic phosphate is removed, and ATP is formed. Here you can call it as acetic acid synthetase. Erythrose 4-phosphate combined with fructose 6-phosphate to form pseudoheptulose 7-phosphate and glyceraldehyde 3-phosphate. In all these condensation reactions, we must write transketolase. Here you write transketolase. Transaldolase. Transketolase, transaldolase, and again transketolase. Thus, we end up in getting 2 molecules of acetyl phosphate and 2 molecules of glycerol 3 phosphate, which helps in forming the acetic acid molecules. Thus, acetic acid. Now, come back to ATP generation. See, in all these concepts, no, ATP generation is only 2, not more than 2. See here, 3 are produced. No, in 3, 1 is used. So, what is the net gain?
2
3 are
ATP.
produced, 1 is used.
3 ATP.
3
Two, sir.
ATP is produced. 1 ATP is used here. Glucose to glucose.
2 ATP.
2 ATP is generated. Net gain. Similarly, even in propionic acid, same way. All the NADH2 is used for reduction reaction, and ATP is only by substrate level phosphorylation. You remember I wrote 4 ATP there in the beginning in case of the propionic acid. There, if you remember,
Yes.
how many net gain will come there?
2 ATP, sir.
4 in 4, how many are used? See here, see the chart. This is propionic acid fermentation. 4 ATP is produced. In this, 2 are used in the glycolysis. 2 are used. So how is the net gain? Among 4,
2, sir.
wait. Yeah, it's 2. I'll tell you once again. This is glucose. Okay, I have written only glycolysis here, general glycolysis here. Yesterday in class also I told you, this one. Glucose becomes pyruvic acid. 4 ATP is formed, 2 NADH2 is formed. All this NADH2 is used in reduction reactions. Only ATP is formed by substrate level phosphorylation. Among the 4, 2 are used in the 2 steps of glycolysis. Correct? Glucose to glucose 6-phosphate, fructose 6-phosphate to fructose 1,6 diphosphate, like that. So what is the, if 2 are used, how many is the net gain?
2, sir.
2 are used. Net gain is 2 ATP. Did you all follow this one?
Yes, sir.
This part is any confusion is there for you in this part? I've done directly here. We are not showing all the steps. In exam, if propionic acid is asked, don't elaborate this. Not required. Understood, all of you? Only write these steps. Don't elaborate that part. Which part? This part is not to be elaborated. Any doubt in this?
Sir, even for 5 marks, we don't have to elaborate.
No.
Okay.
Not required. This is not elaborated. Okay, write the steps involved and importance and all. That's enough. Okay. Clear now?
Yes,
Yes,
sir.
sir.
Okay. Now we have, I'll go with the next pathway. What's the next pathway called? Mixed acid fermentation. Okay, we'll go with the mixed acid fermentation. What is mixed acid fermentation? In the theory, I told you, the lab, I told you, mixed acid fermentation relates to what? Spoilage of, what is it related to? Spoilage of food. And also you have done one test now in the lab called as methyl red test. MR test.
Yes, sir.
MR test, yes, that one. It relates to that one. Okay, I'll clean the board. I'll use this side. So we're talking about mixed acid. Mixed acid fermentation relates to methyl red test. Okay. So now what we will be studying here is E. coli is an example for mixed acid fermentation. Bacillus also is a mixed acid fermenter. They bring spoilage of glucose or food and all. That time they will produce acids. Lactic acid is produced. Formic acid is produced, like that. Okay, let us take glucose for example. I'll write this in. Let us take glucose, which is a 6-carbon compound. Okay, glucose will convert into pyruvic acid, which is a 3-carbon compound. How many pyruvic acids will form? 2. Okay, 2 molecules of pyruvic acid is formed. This pyruvic acid can also form lactic acid. Can also form lactic acid. So to understand here, let us go back here. 2NAD becomes 2NADH2. This NADH2 can be used here. NADH2 can be used here to form lactic acid. Okay. And here you can just show, directly I will show here now. I'll not write that. I'll write 2ADP becomes 2ATP. And again, I'm writing directly here. I told you in the class, we can write like this also directly. This pyruvic acid will convert into acetyl-CoA. 2 molecules of. These are choices. Okay, these are choices. Okay, glucose can give rise to lactic acid. Glucose can give rise to acetyl-CoA. To give other acids, I'll tell you that now. What happens here? Whenever pyruvate converts acetyl-CoA, addition of CoA, removal of carbon dioxide. And here also there is generation of NADH2. Yeah, these are the choices. So NADH2 is formed here also, as well here also. One, this NADH2 can be used in reduction reactions wherever acids are forming. This carbon dioxide can also combine with hydrogen gas and give rise to formic acid. Formic acid. So you remember when you did metal red test, the colors were different, no, every time. Okay. This acetyl-CoA can further undergo steps to form acetyl phosphate or acetaldehyde. I'll show that here. It can form acetyl phosphate or it can form acetaldehyde. Acetyl phosphate or acetaldehyde. Any of this can be formed. When you talk about acetyl phosphate, it can give acetic acid. No, already you know that. Anyway, before that, I'll complete this. CoA is removed. Okay, phosphate is added. CoA is removed, phosphate is added. The enzyme is called CoA transferase. CoA transferase. Acetyl phosphate can convert into acetic acid. Previously, I told you, acetic acid fermentation, like that. So water is added, phosphate is removed. Okay. So that is another important step what we have to follow. So we can call this as acetyl phosphate hydratase. Acetyl phosphate hydratase means addition of water. So there is a choice. Lactic acid can form, formic acid can form, acetic acid can form, and alcohol can also form. See here, acetyl-CoA can also become acetaldehyde. Acetaldehyde can also become alcohol. In both the steps, there is going to be steps like reduction. See here, CoA is removed. NADH2 is added, means hydrogen is added. NADH2 converts to NAD. And here also acetaldehyde becomes alcohol. NADH2 can be used. Like this, you have reduction steps. Here we call it as acetaldehyde dehydrogenase. Any doubts in this? Here acetyl-CoA dehydrogenase, here acetaldehyde dehydrogenase. So hydrogen is added in every step to form different products. So NADH2 is used in many places. So NADH2 cannot give energy. Net gain of energy means only 2 ATP by substrate level phosphorylation. So when you recollect methyl red test, when you do the addition of methyl red reagent, you can find sometimes color to be pink, sometimes color to be red. No, that is depending on how much of formic acid is produced or alcohol is produced. When alcohol is there, alcohol will reduce the dye by itself. So that's why the pink color will become little lesser intensity. So it can happen where microorganisms are able to convert these compounds, no, Sometimes lactic acid is high and acetic acid is high. It may give you dark pink color. The other ingredients might reduce the color that way. That's how we can understand that mixed acid fermentation is important when you consider a methyl red test, and as well, it's also related to spoilage of food. Okay, when food gets spoiled, the acidity is high because of the mixed acid fermentation, which is brought by bacillus, which is a very common bacteria. E. coli can bring it very commonly. That's why it's one of the important things in study for mixed acid fermentation become related to spoilage of food. So when you're reading food microbiology, dairy microbiology in the coming semesters, in 5th semester, that time you'll understand that this is a basic principle. But you'll only read the spoilage pattern. But you should also remember that this is the major physiology behind that one. Are you clear, students?
Yes, sir.
Yes, sir.
Okay, you're able to understand till here? Okay, no? We have 2
So
minutes
which is
left.
the,
Yes, tell me.
excuse me.
Yeah.
So which is the enzyme used in acetyl phosphate to acetic acid?
Yeah, this one, nah?
Yes, sir.
You can call it acyl phosphate hydratase.
Okay.
Hydratase. Because water is added.
Okay, sir.
Okay. Do we have time for the last one? Butanediol fermentation? Or it might delink because there's only 2 minutes left. Shall we continue in the theory class? In college, Monday?
Yes, sir.
Yes.
Okay, okay. So attendance, you please take it, no? Harshit? Harshit
Yes.
is there or is there, no? He was there, I saw him. Harshit?
Yes, sir.
Okay, we'll continue on Monday. Do you have any time?
Yes, sir.
You see and tell me. Huh? Okay. Monday you have lab, no?
Yes, sir.
Please get your records, ma.
Okay, sir.
Get your records for correction. Try to get it finished off that day. It means you give it and go. Next day you can collect it. Like that. Okay. Fine, students. Take care. We might delink anytime. It's just a minute now. So we've learned 3 fermentations today. Propionic acid, mixed acid, and which one did you learn? Acetic acid. Okay. Next class we'll complete it and go for photosynthesis chapter.
Okay, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Bye.
Good evening, sir.
Thank you, sir.
Thank you. Delink. Portions I'll send it to you. Theory portions I'll send it for test.
Okay, sir.
Okay.